Hello to one and all who are watching this video. We are going to solve a problem from design of transmission systems subject, and we are going to solve a problem in the topic spur gear. Basically, in some problems, the pinion and gear wheel can be different material. The pinion can be steel and this one can be cast iron. But in this problem, what they have given is both the pinion and gear are made up of steel. So here the both are made up of same material. So first of all, if we are going to solve a problem, then we have to read the question first, and you have to write the given data which is given in the question. So first, a motor shaft rotating at 1500 rpm has to transmit 20 hp to a low speed shaft with a speed reduction of 3. The teeth are 14.5-degree involute with 25 teeth on the pinion. Both the pinion and gear are made of steel with a maximum safe stress of 2000 kgf per centimeter square, a safe stress of 400 kilogram force per centimeter square may be taken for the shaft on which the gear is mounted and for the key. Design the spur gear drive to suit the above conditions. Assume the starting torque to be 24% higher than the running torque. So this is the question given. So given data which is given in the question is first one, a motor shaft running at 1500 rpm. So the speed of the motor shaft is given, which is taken as n1, that is equal to 1500 rpm, and that motor shaft is transmitting a power can be written as P, that is 20 HP horsepower is transmitting, and a speed reduction of 3. The speed reduction and speed ratio, transmission ratio, gear ratio all are same. So it can be written as small I, that is equal to 3, and the teeth are 14.5-degree involute. So this is the angle, that means a pressure angle which is given in the question. So the pressure angle can be written as alpha, that is 14.5 degree involute, and the another data they have given is both the pinion and gear are made of steel. So here both pinion and gear are made of same material, made of steel. So both are same material. And so that, and what they have given is the safe stress for that is 2000 kilogram force per centimeter square. So that means safe stress means sigma B design value, that is equal to 2000 kgf per centimeter square. If a value is given inside the bracket, then it is considered as design value. In case if bracket is not given, then that value will be considered as calculated value. The difference between design value and calculated value is design value is if the calculated value is multiplied with any, if a calculated multiplied with any factor value, for example ks or kd, whatever it is, then that final value will be considered as the design value. So the design value will be always greater than the calculated value. So we have to understand the difference between design value and the calculated value. Here in this question they are given is design value. The another important data they have given is teeth, number of teeth they have given, that is Z1, that is equal to 25. Here they have given 25 teeth, that means Z1 is equal to 25. Here the strip stress for the shift stress for the gear and pinion material, that means the steel material is given, which is 2000 kilogram force per centimeter square, and another safe stress for the shaft, which is a different material, is given, that is safe stress for shaft is given, that is 400 kgf per centimeter square, as you can see. So these are the data which is given in the question. So we have written all the given data which is required to solve the problem. So now what we have to do is we have to find the there are almost 3 steps need to be followed in order to design a spur gear. The first step is we have to find, in the first step we have to find the module M. So in order to find the module M, first of all we have to find beam strength. That is equal to F of S. So in order to find the F of S, we have a formula, sigma B of B into Y into P of C. With this formula you can easily find this formula in data book page number 8.50. So here we have, in this formula we have the value of sigma B. This is the safe stress value of pinion and gear. So we can directly use this sigma B value here. And another value, this B, this is known as face width. We don't have this particular value. For that we have a formula. So B is equal to 3 of PC, and the face is nothing but the 3 times of the P of C value, and the P of C, that is equal to pi into P of C is equal to pi into M. M means the module. So we have, therefore the B will be 3 into this way. Instead of P of C we can put the value of pi, we can substitute pi into M. So therefore B will be 3 pi m. So if we can substitute this value for the value of b. So and what another data we have to find here is the small y. To find the y, we can use the formula y is equal to 0.124 minus 0.684 divided by z1. So this formula can also be found out from data book page number 8.50. So we can simply substitute the value of z1, the z1 value, that is equal to 25 number of teeth. So if we substitute the value of z1, which is 25 here, we can find the value of y. So y is equal to 0.124 minus 0.684 divided by 25. So if we calculate this value using the calculator, then we can find out the value of y, which is 0.09664. So this is the value for small y. Here we have to choose this formula for 14.5 degree involute. So in data book page number 8.50, we have to find the formula of y, which is for the corresponding value of 14.5 degree involute. So we can find this formula from the data book. So if we substitute the value of z1, which is 25, we can find the value of y. So now we have found the value of y, b and p of c and b. So we can substitute all these values in this equation, f of s equation. We can consider this equation as equation A. So put the values of, we can put the values of b small y and p of c in equation A. So the equation A will be f of s is equal to sigma b. The sigma b value is already given in the given data, which is 2000. We can put that value directly here, 2000 into, and the b value is given here, which is 3 into pi into m, 3 into pi into m, and the value of small y, which is 0.09664, can be written here, and the value of p of c, which is pi into m, can be written here. So these are the values we have got. So if we calculate this value, then here we can found that these constant values can be multiplied using the calculator. So if we calculate those values, then the value will be 5722.79. Here the m value of m, that means the model is unknown, so we have to keep here. So m into m will be m square. This is a unknown variable. So for unit for the f of s, that means beam strength is equal to kilogram force. So this is the value we found for the beam strength, that means f of s. So the f of s value we have found it, and after we found the f of s value, we have to find the value of dynamic load, that is f of t. To calculate the dynamic load, we have a formula for that. That formula is that is f of t into cv, which is given in the data book page number 8.50. And to calculate the value of f of t, we have another formula that is equal to hp into 75 divided by v of m, that is also can be found in the data book page number 8.50. These formulas are can be found in data book page number 8.50 or 51 for the spur gear. We have to choose these formulas because it is for spur gears, not for bevel gear or helical gear or worm gear. You have to choose the formulas of FD for spur gear. And for calculate the value of f of t, we have to calculate the value of mean velocity Vm. So for calculating the value of mean velocity, we have another formula, that is pi into d1 into n1 divided by 60 into 100. So for to find out the value of d1, we have another formula, that is z1 into m, which is also given in the data book page number 8.22. So for z1, we can put the value 25, which is given in the question itself, number of teeth, that is z1 is equal to 25. So the m is model, which is unknown variable, so d1 is equal to 25 into m. So now put this value in this equation of v of m. So we can the value of v of m will be pi into 25m into 1500. 1500 is nothing but the n1, and this is the value of d1, and here the 60 into 100 is coming here. Now if you put this value, calculate these values using calculator, then we can find the value of v of m, that is equal to 19.634 into m. This m is nothing but model, which is unknown variable, and the unit is meter per second. So we have to put this value of mean velocity in this formula f of t, that is equal to hp into 75 divided by v of m. So by putting this value of Vm here, we can find out the value of f of t. So now f of t, that is equal to hp, instead of hp we can put the value of 20, which is given in the given data, into 75 and divided by v of m. Instead of v of m, we can write this value 19.634 into m. So by calculating this value, we can find v of t, that is equal to 76.398 divided by this value is unknown, so we have to keep that value m. So we have found the value of f of t. The unit for f of t is kilogram force. So we found the value of f of t. So we have to keep this value, and now again we have to find the value of c of v. So for calculating that c of v, we have another formula, c of v, that is equal to 6 plus v of m divided by 6. This formula can be find from data book page number 8.51. Here this value has to be chosen because the value of v of m is greater than 20 meter per second. Here the value of v of m we have found is 19.634, which is almost equal to the 20, and there is another value called m. If we put the value of m, then this value will be more than 20. So for calculating the value of v of m more than 20, then we have to consider this formula for calculating c of v, 6 plus vm divided by 6. The data book page number is 8.51. So now here we have to put the value of v of m here, and we have to find the value of c of v. So c of v is equal to 6 plus 19.634 m. This m value is unknown, so we have to keep that value, divided by 6. So we have the value for C of V and F of T. So now we can put the values of C of V and F of T in the equation, which is F of D is equal to F of T into CV. So F of D is equal to, put the values of F of T. So F of T is equal, what is F of T? That is, we have found F of T is equal to 76.398 divided by M, and the value of C of V, that is equal to 6 plus 19.634 divided by 6. So these are the values we have found for F of T and C of V. So now calculating these values, this M, that is also have to written. So by calculating these values, we can found F of D is equal to 12.733 into 6 plus 19.634 m divided by m. Here this value found out because we have divided this value with the 6. So we found 12.733. We have kept these values. So now we have found an equation for F of D, and here the value of module is unknown. We are keeping that value. So we can consider this one as equation 2. So from equations 1 and 2, we know that the first equation is f of s, that is equal to some value we have found earlier, and now the value of f of d we have found something. This we have considered the term as f of s as equation 1, the value of f of d as equation 2. Now we are equating the both equations. So here the f of s, there is a formula to calculate those, comparing those values. F of s value always should be greater than or equal to f of d. So if we consider f of s is equal to f of d, then here we have to check whether this condition is satisfied or not. For that we have to put the value of f of s and f of d. Here the f of s value is, as we found out earlier, 5722.79 m square. This m is nothing but the module. It is equal to 12.733 into 6 plus 19.634 m divided by 6. So we have to check this condition satisfies or not. That means f of s is equal to f of d or not. We have to check this condition. Sorry, this one is not 6, this one is m. So now this m we can this m can go this side. So now the value can be rewritten as, and also here the 5000 something can be, these two values can be divided. If this value goes this side, then this both will be divided. So we can find get a certain value using the calculator. That value is 449.44, and this m, if it goes this side, then it will be m cube. So the final value can be 449.44 meter cube, and this value will not be changed, so we have to write it here, 6 plus 19.634 m. So now we have found another equation. So for calculating the value of module, we have to follow trial and error method. So to calculate module m, we have to follow the trial and error method. Trial and error method. So in this trial and error method, we can give the value for m. The values like 0.5 centimeter and 0.4 centimeter and 0.3 centimeter, and these kind of values we can use for this for the m, and we can check whether this condition is satisfied or not. So first we can check the value of 0.5 centimeter for m by putting the value for m as 0.5 centimeter. We can see whether the condition is satisfied or not. So trial 1, for trial 1 we are putting the value of m is equal to 0.5 centimeter. We are considering this value. So if we put value 0.5 instead of m, then it will be 0.5 power 3, and this value will be multiplied with the 0.5 will be multiplied with this value, and if you put the values in calculator, then we can find a certain value on for the LHS and RHS. So that LHS value and RHS value should satisfy this condition. Whether if we calculate, so 449.44 into 0.5 cube, that is equal to 6 plus 19.634 into 0.5. So if we calculate this value using the calculator, if we calculate this value using the calculator, then the LHS value will be so the LHS value will be 56.18, and the RHS value will be 15.817. So whether we check this condition here, the LHS, so the condition, what is the condition? It is the f of s should be greater than or equal to f of d. So now we are checking this condition. In this condition here, the f of the LHS is greater than RHS. Yes, condition number 1 is satisfied, but the another condition is it should be equal, greater than or equal, but the difference between both of them is very large. So therefore the condition is it is satisfactory. The condition is satisfied. The condition is satisfied, but the value of m is too big, but module is too big, but the m value is too big. So if the values LHS value is the difference between the LHS value and the RHS value is more, then the value of m will be also more. So this cannot be, this 0.5 cannot be considered, this value cannot be considered for the model. So now trial 2. M is equal to 0.4. So same like we put this value instead of 0.5, then we can find LHS value is equal to 28.764 and RHS value is equal to 13.8536. Here same condition, the condition, therefore here it is also satisfied. LHS is greater than RHS, but it is not equal, the difference between them are too big. So satisfied, therefore it is satisfied, but the m value is too big. M is too big. That means the difference between them is very big, therefore the model value is also too big, so it is not also accepted. So now again trial 3. M is equal to 0.3 centimeter. So therefore LHS will be 12.134 and RHS will be 11.69. Now here it is also satisfied, the LHS is greater than RHS and the difference between them is just 1, so it is very small, therefore the condition is fully satisfied. It is LHS is greater than RHS, almost equal to the, both values are almost equal, the difference between them is not so big, therefore the condition is satisfied. We can consider the m value as 0.3 centimeter. And also we can check trial 4. So it is almost equal, so we can put the value for m as 0.29 centimeter to check whether this value is right or not. If you put that value as 0.29, then the LHS value will be 10.96 and RHS value is equal to 11.69. This value we will get if we put the value of m is equal to 0.29 in this equation. So Here the condition LHS is smaller than RHS. Therefore, the condition is not satisfied and this is totally unacceptable. So the final answer can be the acceptable answer is M is equal to 0.3 centimeter. Therefore, it is not satisfied. Therefore, we should take the value of M is equal to 0.3 centimeter. This is the value for M, which is found out by the trial and error method. So now we have found the value of M. So we can calculate the phase width value. Now we can find phase width. Phase width that is equal to small b. So we know that the b is equal to the phase width b is equal to 3 into pi into m. So we know we found out the value of small m. So now we can find the value of b, that is nothing but the phase width. So phase width that is equal to 3 into pi into the m value is 0.3 centimeter. So here the value of m is in centimeter. So we have to change this unit from centimeter to millimeter. So for that we know very well that for converting this unit from centimeter to millimeter we have to multiply it with 10. Therefore b will be 3 into pi into, so 0.3 into 10 it will be 3. So the unit will be converted into mm. Now so b is equal to if we calculate this value in calculator, then the value of b will be 28.274 and the unit will be mm, because we have changed this centimeter unit into mm unit. So the final value of b is equal to 28.274 mm. So now we have completed the step 1. We have found the value of m as well as the value of phase width b. Now the step 2, in this step 2 we have to find, we have to check the beam strength. In step 2 we are checking the beam strength. So to calculate that we have to use the formula of Buckingham's dynamic load formula. That is nothing but f of d. So this formula also given in the data book. For f of d, calculating f of d, there is a formula, that is f of d plus 0.164 v of m into cb plus f of t divided by 0.164 vm plus 1.485 root of cb plus f of t. This is a square root value. So here the value of f of t and the value of v of m and the value of c and the value of b and the value of again f of t and the value of all these values has to be calculated separately, and all these values again should be applied in this equation to find the value of f of t. So uh, first, so initially we have to find the value of f of t. So here the f of t we have already found. The f of t, that is equal to 76.398 by m. This is the value we have found. So instead of m we can put the value as 0.3 centimeter. So the centimeter value can be applied here instead of m. So f of t, that is equal to 76.398 divided by m. Here 76.398. So the m value we are putting the centimeter value, which is 0.3, that is equal. Therefore, if you calculate this value in using the calculator, then the final value will be 254.66 kgf. So whenever we are calculating f of t, we have to put the centimeter value of m. Then only we can get the unit kilogram force for f of t. So you should not forget, you should not put the value of value. That means we should not put the value 3 for m, that is the value, millimeter value. Here we should put the value of m in centimeter. Now we can calculate the value of v of m. So v of m, that is equal to, we already found the value of v of m, that is equal to 19.634 into m. Here we can put the value of m as 0.3. Here also we have to apply the centimeter value. So v of m is equal to 19.634 into 0.3 into, we are applying here against this, the value that we are getting, that is the vm value is in meter per second. Here this is the unit of v of m here is meter per second. So we are here for applying the value of v of m here, the unit should be in minute. So for that we have to multiply the value with 60 in order to convert this second into minutes. So then the unit will be meter per minute. So now the v of m value will be 353.412 meter per minute. So we have found the value for v of m, and also we have found the value for f of t. Now we have to find the value for small b. So small b, that is equal to, we have already found small b is equal to 3 pi m. Here we have already found the value of small b, that is equal to 28.274, that is in mm. So here all values are in centimeter. So we have to convert this value into centimeter value. So the b value will be 2.8274 centimeter, because here we have to apply the centimeter values to find out the value of f of d. So now we have to calculate the value of c, small c. So for that we have to use the formula, that is c is equal to 11440 into small e. This formula can be found out in data book page number 8.53. So in page number 8.53 there is a table to find out the value of c, and for this particular value, this particular formula has to be chosen for steel, because in the question itself it is given that the material is made up of steel. Both the pinion and gear is made up of steel, so we have to consider this formula from that table, which is given in the data book page number 8.53. Here the value of V has to be considered as 0.025 mm. This value also can be found out in data book, the same page number 8.53, in another table for calculating E. Here this is considered, the value of E is considered as 0.025 because the question itself it is given that carefully cut gears. So this value is chosen for E because here it is given as carefully cut gears. We have to choose this one for our respective this. We can find the value of E is equal to 0.025. So we got the value of E, so we have also another value, so we can easily calculate the value of C. So multiplying this value and this value, we can calculate the value of C. Therefore C is equal to 11440 into 0.025. Therefore the value of V after multiplying this unit and the value of this unit, so after multiplying that, the value we found is 286, and the overall unit for E, sorry, the small c will be changed to kilogram force per centimeter. Actually the value we found in the data books mm, but when calculating this value and this value, the overall value for c will be considered as kgf per centimeter. So we have found the value of small c, and now we can put all these values we have found in f of d equation. So f of t, we know that the value of f of t here, that is 254. These values, all those values you have. So for calculating the f of t and vm, all those values we have found are here. We have to apply these values in this equation to find f of t. So f of d is equal to f of t value, that is 254.66 plus the value of 0.164 into 353.412 and 286 into, so here because of the limitation of the page, I will write the other coming values in the down here. So 286 into 2.8274 plus 254 0.254.66. So divided by 0.164 into 353.412 plus 1.485 into square. Here also the page, there is no space here, so I'm writing the values down here. Square root of 286 into 2.8274 into, sorry, this value is plus 254.66. These values are coming under this square root. So this is the continuation. This value, because of the limited space, I'm writing the value which is inside the square root as here. So if we calculate this value using the calculator, then we can find f of d, that is equal to 833.97 kilogram force. So we found the value of f of d, and now we have to calculate the value of f of s, that is equal to 5722.79 m square. This value we have already found. Here f of s equal to 5722.79 m square, the equation 1. So in that equation we have to put the value of m is equal to 0.3, the centimeter value. F of s, that is equal to 5722.79 into 0.3 square. Therefore if we calculate this value using the calculator, f of s will be 515.05 kilogram force. So we have calculated the value of f of s. Here f of s is, here the f of is smaller than the f of d. Therefore the design is not satisfied. Is not satisfied. Is not satisfactory. Based on beam strength. We are, as we already said, f of s should be greater than or equal to f of d. Here the f of s value is smaller than f of d, therefore the design is not satisfactory based on beam strength. Therefore we should go for the higher value of m here. So we have considered three value like 0.3, 0.4, 0.5. Here 0.3 is not satisfied for f of s, so we have to consider higher values of m. That is nothing but therefore m is equal to 0.4 or 0.5 has to be centimeter, has to be considered. So if we put the same value of here, instead of 0.4 the final value for f of s also will be smaller than f of d. Therefore, if we put the value of 0.5, the value can be higher than f of d if we use if you calculate this value using the calculator. So we can consider m is equal to 0.5 centimeter. So only if you consider this value, the f of s value will be greater than f of d. So if you put 0.5 value of 0.5 in here, then the value will be so again now the value of m is equal to 0.5 centimeter is considered. So therefore the f of d value will be also changed and the f of s value will also be changed. So again we have to find f of d. We know the formula for f of d, that is f of t plus 0.6164 v of m c b plus f of t whole bracket divided by 0.164 v of m plus 1.485 into square root of c b plus f of t. So we know this equation. We have to put we again for that we have to calculate f of t. So f of t is equal to 76.398. The value will be, instead of 0.3 we are putting the value of 0.5 here, and also we, instead of using 0.3 we are using 0.5, and also here also. So every value will be changed, even the b value also will be changed. Instead of 3 we have to put 5 here. So every value will be changed except this c value, because we are not applying m here, the value of m here. M is nothing but the module. So again f of d will be, so for calculating the f of d we have to find f of t, that is equal to 76.398 divided by m. So here 76.398 divided by 0.5. So the value will be 152.796 kgf, and v of m, that is equal to 19.634 into 0.5. This is, instead of m we are putting that, into 60, then that will be 589.02 meter per minute. The unit will be, because we are converting that seconds into minute by applying 60. And b, that is equal to 3 into pi into m, that is equal to 3 into pi into m 0.5, that is equal to 4.712. And now we can apply all these values in f of t. We know, as I said, applying in this equation. So f of t is equal to, instead of f of t we can write 152.796 plus 0.164 into 589.02, this value, into 286 into 4.712 plus 152.796 6 bracket, open bracket is closed here. Now divided by 0.164 into 589.05 plus 1.485. The square root value here, because of the insufficient space, I am writing the value of square root here. Okay, I will try here. Write the value inside the square root here. 286 into 4.712 plus 152.796. This also comes under the square root. Because of the insufficient place, I am writing it here. So if we put this value in calculator, we can find f of t is equal to 1131.43 kgf, kilogram force. And here f of s, for calculating the f of s, we can use this equation 5222.79 into m square. So instead of m, you can put the value of 0.5. So 5222.79 into 0.5 square. If you calculate this value using the calculator, then we can easily find the value of f of s, that is equal to 1430.69 kgf. So here the f of s value is greater 1430 and the f of t is 1131. Here the f of s value is greater than f of t, hence the condition is satisfied. Hence f of s is greater than f of d, therefore the condition is satisfied. Is satisfied. Now we have finished the step 2. Now we can go to the step 3. Here we have to check for wear strength. Check for wear strength. Here to check the wear strength, we have to calculate the wear load first. Wear load, that is equal to f of w, that is, for calculating the f of w, we have a formula for that, that is d1 into q into k into b. This formula is given in the data book, page number 8.50. So to check the wear strength, we have to calculate the wear load first. So here we have to calculate the value of d1 and q and the value of k and value of p. So for these we have separate formulas for that. Here we should use m value, that is equal to 0.5 centimeter, not 0.3. Here we have to the module value as 0.5 centimeter. So you should keep it in your mind, because in step 2 also we have used 0.5 also. So now to calculate f of w, we have to first calculate the value of d1, that is equal to m into z1. The formula to calculate d1 is equal to m into z1, which is can be find from data book page number 8.22. As I said earlier, this formula can be found in data book page number 8.22. Okay, so the M value is 0.5 and Z1 is 25. Therefore, D1 value can be easily found that therefore the D1 value that is equal to 12.5 centimeter. Here the 0.5 is value of M, that is also centimeter value. So we found T1. Now we have to calculate the value of Q, that is the formula for Q is 2I divided by I plus 1. So it can be, it is also given in data book page number 8.51. So the value of I, we know this is nothing but the gear ratio or transmission ratio or speed reduction. Here the I is that is equal to 3, which is given in the question itself. So Q is equal to 2 into 3 divided by 3 plus 1, that is equal to 6 by 4, that is equal to 1.5. So the Q value is 1.5. So now we found the value of Q, and we know the value of B is equal to 4.712 centimeter, which is calculated in this step 2. So this is, we have calculated already in this step 2. We have put the value of M is equal to 0.5. Same answer here. B is equal to 4.72 centimeter. So again we have to calculate now the value of K. For that we have a formula for that. Sigma C square sin alpha divided by 1.4 bracket E1 plus 1 by E2. So here the value of sigma C we have to calculate because it is not given in the question, and alpha it is given, that is nothing but 1.4, sorry 14 point, sorry, the value of alpha which is given in the question is 14.5 degree, and the value of Young's modulus 1 and Young's modulus 2 is not given in the question. So these values we have to find. So first we have to find the value of sigma C. This is nothing, this is a design value of sigma C, not the calculated value, because we have put it inside the closed bracket. So the design value for sigma C, that is, for calculating that we have a formula for that. That formula is C, capital C base R into HRC into K base CL. This formula is also given in data book page number 8.16. So we have to find the value of CR and HRC and KCL in order to calculate the value of sigma C. So we know in the question it is given that the pinion and gear is made up of steel, so we can assume the steel is given, but we can assume it is alloy steel because it is not given which type of steel it is. So we can assume it is an alloy steel and case hardened. The question it is given only steel, so we can assume it is alloy steel and it is case hardened. So for this particular criteria, by referring the page data book page number 8.16, we can find the value of CR and HRC. So the CR is equal to CR and HRC and KCL can be found in the data book page number 8.16. CR, therefore CR can be found as 280 for alloy steel, and HRC will be in the range of 55 to 63. So here in the data book the range for HRC will be given, so we can consider 60. It is our choice, we can consider 60. So HRC, I am here considering the value of HRC is 60. So, and the value of KCL, the KCL value can be found from the data book page number 8.17. For calculating the value of KCL, we can go to the page number data book 8.17. so where we have to, there is a tabular column given. In the tabular column we have to assume the surface hardness value is greater than 350 because it is not given in the question. So in case if it is not given, we have to assume the surface hardness is greater than 350, and we have to calculate the life for the material, that is equal to, and here also if the life hours is not given, then we have to also assume life hours, that is equal to 10,000 hours. This is also have to assume, you have to assume if it is not given. So for n 10,000, that is the 10,000 hours into, it is given in hours, so for convert it into minutes we have to calculate it with 60 and 1500, which is the speed, that is the n1 speed which is given in the question, n1 1500. So if we calculate these values, then we can find using the calculator. If you calculate this value, then life n, that will be 90 into 10 to the power 7 cycles, so which is greater than 20 into 10 to the power 7 cycles, and surface hardness is also greater than 350. So from the table for KCL, data book page number 8.17, we can find the value of KCL, that is equal to 0.585. So we also find the value of KCL now, and also we found the value of CR. We also find the value of HRC. Now we can easily calculate the value of sigma C. So therefore sigma C, the design value of sigma C is equal to 280 into 60 into 0.585. Therefore the design value of sigma C is equal to 9828 kilogram force per centimeter square. So we found the value of sigma C. So now we have to know what is the Young's modulus values of that means the Young's modulus value of E1 and Young's modulus value of E2. So for that, to find the value of E1, here the Young's modulus value of pinion and Young's modulus value of gear both are same, because the pinion and gear are made up of same material. Therefore E1 is equal to E2. So this value can be easily find from data book page number 8.14. So for a steel, we can easily find the Young's smallest value from data book page number 8.4, that is equal to 2.15 into 10 to the power 6 kgf per centimeter square. This is 6. So we found the value of E1 and E2 and sigma c. Now we can easily calculate the value of K. Therefore, here we already have the equation to calculate K. We have to put the values of sigma c and E1, E2 and alpha. Alpha is nothing but the pressure angle which is given in the question, 14 point. Just wait, I will show you that value. Yeah, this is alpha value which is given 14.5 degree. That means 14.5. The half means 0.5. Therefore alpha, that is also given 14.5 degree. So that can be written as 14.5 degree alpha value. So we also got the value of alpha. Now we can easily calculate the value of K. So for calculating sigma c value 9828 square, because here sigma c is squared here, into sine 14.5 degree divided by 1.4, like it 1 by 2.5 into 10 to the power 6 plus 1 by 2.5 into 10 to the power 6. So now if we put these values in calculator, we can find the K value, which is 16.069 kgf per centimeter square. Now we found the value of K. So now we can easily calculate the wear load F of W, because we know that for calculate the F of W, we have to know the value of D1, Q, K and B. We already found D1, Q and B, and now we found the value of K also. So we can easily calculate the value of F of W. So we know F of W, that is equal to D1 into Q into K into B. So those values are 12.5 into 1.5 into 16.069 into 4.712. Therefore F of W is equal to 1419.69 kgf. So now we have calculated the value of F of W. Okay, I think you can see the value now. So F of W, that is equal to 1419.69 kilogram force. So we have already calculated the value of F of D. That is, which is in the step 2. The step 2, we have already calculated the value of F of D, that is 1131.43 kilogram force. Now we have calculated the value in step 3. We have calculated the value of F of W. So F of D, that is equal to 1131.43 kgf. So Here the f of w value is greater than f of d because it is 1419 and f of d is just 1131. Therefore, since f of w is greater than f of d, the design is satisfactory. The design is satisfactory based on wear strength. And therefore the final values for m model is equal to 5 mm, that is equal to 0.5 centimeter, and b face width, that is equal to 4.712 centimeter, which is already found. Okay, we have find the final values. So thank you one and all for watching this video.